For the last 50 years, the story of computing has basically been about one thing: getting bigger, more power, more cooling, more concrete poured into massive buildings. But today, we're going to explore a really profound shift, a quiet turning point where technology isn't just getting smaller and smarter, it might actually be revealing a much deeper truth about creation itself.
Okay, so here's how we're going to break this down. First, we'll look at the old world of these giant data centers. Then, we'll dive into the two big revolutions in hardware that are changing absolutely everything. We'll see what happens when those two forces merge, and that's going to lead us to a pretty fascinating question. Are we inventing the stuff or discovering it? From there, we'll touch on the idea of a divine blueprint and wrap it all up with what it means to start thinking like a forest.
So, let's start with the world we all know, right? The age of these electronic giants. For decades, this has been the only way we thought about it. Progress was measured by sheer brute force scale: bigger buildings, more power lines, more concrete.
And this really frames the entire conversation. We're seeing a fundamental shift away from what you could call the Colossus model, a single, massive, centralized giant, and we're moving toward the constellation, which is a distributed network of smaller, smarter, interconnected lights. To really get your head around the Colossus, you have to understand its thirst for power. A single traditional hyperscale data center can suck down hundreds of megawatts. That's enough to run an entire city. This has literally chained our digital intelligence to the electrical grid, making it incredibly dependent and, honestly, pretty fragile.
So, why on earth did we build them this way? Well, it was all based on a set of assumptions that we just took for granted. We assumed processors would be inefficient and pump out tons of heat. We assumed the connections between them were fragile. And we absolutely assumed you needed a massive centralized grid to power the whole thing. We built these sprawling monuments based on a fundamentally flawed idea that intelligence has to equal heat and waste.
But that whole era, it's coming to an end. And it's all thanks to a dual revolution in hardware. There are two key technologies that are converging right now to create a completely new picture and totally change the game.
So first up is this little miracle, the NVIDIA DGX Spark. I mean, forget warehouses full of servers. This thing is a micro supercomputer, about the size of a stack of hardcover books, and it delivers a petaflop of AI performance. That's a quadrillion, a 1 with 15 zeros, calculations per second. It's just an insane amount of power in a tiny, tiny box.
So how is this even possible? Well, the genius is in the design. By putting the CPU and the GPU right next to each other on these silicon bridges, it gets rid of almost all the wasted energy from electrons having to travel between different chips. Something that used to require a cooling system the size of a swimming pool now runs on just a few hundred watts. This right here breaks that old link between power and heat. Okay, so that's the computation piece. That's the brain. Now for the second half of this revolution. The power, the lungs. This is the Bloom box. And it's not a noisy generator. It's a silent column of fuel cells that creates electricity directly through a chemical reaction. It's completely unchained from the grid. And the advantages here are just stunning. There's no flame, no combustion, so it's nearly silent and has almost zero emissions. It's incredibly efficient. We're talking over 80% if you recycle the waste heat. And get this, it can run on natural gas today and seamlessly switch over to green hydrogen tomorrow. It's like the missing organ that finally lets computation breathe on its own. All right, so we've got a tiny supercomputer, and we've got a clean local power plant. The real magic, though, happens when you put these two together. What kind of new digital ecosystem does this actually create?
The change is just staggering when you see it side by side. The scale shifts from a massive gigawatt campus to a tiny kilowatt constellation. The power source goes from a fragile central grid to a robust local fuel cell. A footprint the size of a city shrinks down to something that could fit in a neighborhood substation. The key thing to get here is that this isn't just an improvement, it's a complete paradigm shift.
Let's put some real numbers on that, because this is wild. A single Bloom box, that quiet, efficient fuel cell, can power about 450 of those little DGX Spark nodes. Together, that cluster delivers around 200 petaflops of performance. That is more powerful than an entire national supercomputer from just a decade ago, all running quietly in the space of a few parking spots. Just think about that for a second.
And the implications here are massive. They go way beyond just engineering. Economically, this could break the monopoly of the giant cloud providers. Environmentally, it nearly eliminates the energy lost in transmission, and it slashes carbon emissions. And socially, it democratizes everything.
a hospital, a university. They can now have their own sovereign supercomputer. Technology stops being this alien thing in a giant building far away and becomes, well, neighborly.
So we've seen this incredible technological leap, but it really forces us to step back and ask a much deeper, more profound question about what innovation even is.
Is what we're witnessing here just clever engineering? Is it a purely human invention? Or when we create something this efficient, this harmonious, are we simply uncovering a pattern that was waiting to be discovered all along? Let's dig into that idea.
To explore that question, we can actually turn to a completely different kind of source text, one that gives us a framework for understanding not just technology, but pretty much all human works. This ancient verse from the book of Ephesians suggests something pretty radical. It suggests that our greatest achievements, they don't actually originate with us at all. Instead, it's like we're instruments, and we're just fulfilling a divine design that was prepared for us before we even got here. The treehouse metaphor from the source material makes this idea super clear. Imagine a kid who thinks they're inventing a treehouse, right? But the design, the tree itself, the wood, the very laws of physics that hold it all together, all of it was already provided. The joy isn't in creating something from nothing, but in participating in a plan that was already laid out. And this brings us to the core of this whole perspective: innovation as revelation, not origination. From this point of view, even our most advanced technology, like the beautiful convergence of the DGX Spark and the Bloom Box, could just be us uncovering a pattern of efficiency and harmony that God hid within the possibilities of matter all along.
So what happens when we bring these two big ideas, the technological and the theological, back together? Well, we get a pretty stunning, unified vision of the future. And what is that vision? It's a future where our digital civilization computes the same way a forest grows. Not like a single monstrous tree, but as a thriving ecosystem. Incredibly dense and complex in its structure, but with almost zero waste. This new model of technology perfectly mirrors the architecture of life itself.
This brings us to the final convergence. This is the point where technology finally makes peace with ecology. Instead of devouring energy from a grid, our digital networks can photosynthesize it locally. Thought itself just becomes a form of efficient energy management. We could finally learn how to turn chemistry into consciousness, without all the waste.
Which leaves us with this final, kind of poetic thought. Perhaps the end goal of all our work, of all our invention, isn't to create something new at all. Maybe it's just to chip away at all the unnecessary parts, the heat, the waste, the noise, to reveal an order that was always there, an intelligence so perfectly efficient that it becomes indistinguishable from pure light.